Okay, hello 20-1s. So what I want to do for this one, this lesson's called discriminants. And I'll explain what that means in a minute here. But what I'd like you guys to do for this lesson is really just these 9 questions. And when we do them, we're going to do each of these things. So A to E. We know how to do A, if you can do it. Some of these you won't be able to actually solve it by factoring, so we'll have to use B, the quadratic formula. And then this one says change each equation into a function that you can graph and then sketch each function to actually accurately show zeros. You guys did this in grade 10, but I'll just maybe go over it quick to remind you. All you'd really do for these ones is change this equation. Instead of being 0, we've set y equal to 0. So the original equation here was y is equal to x squared minus 4x minus 12. So that's what I mean. So just rewrite it like that. And remember that this y, that can just as easily be written as f of x is equal to x squared minus 4x minus 12. And the reason why I bring that up is because in your calculators, if you have a TI Inspire, it looks like this, f of x. So let's say that this is what I want you to graph. So what you guys would do is go to Home and then Graph. And then you're going to end up with a screen that looks something like this. Your window might be a little different depending on what you're graphing last. If you want to make sure that you start from scratch, go Home and then go New Document, so number 1. And then just start a new document. And then it should start you with the same kind of window I have here. It goes -10 to the left, 10 to the right, -7 down, +7 up. So you can see right up here it says f of 1 and then x. It just means that's the first function and f of x. So it just means this. So all you have to do is put in x squared. So x is down the bottom there, right? X and then just the squared button minus 4x minus 12. Push enter. It's going to look something like that. Now, one thing you might forget, this looks like the window is pretty good for us to see in the x, right? So from the left to the right. But I can't see the bottom of this parabola. I can't see the vertex of this parabola. So what I'm going to do is change my window setting. So right now you can see it goes down to -7.3 or 7.4. Let's change that to like -15 so we can see the bottom of it. So what I'm going to do is go Menu, Window Zoom, Window Settings, so there's number 1, and then Y minimum. Right now you can see that Y minimum is set to negative yada yada yada. Let's change that to Y minimum of, let's say, -15. And then OK. And now I'm not quite low enough, so I was wrong with my initial guess, so I'm going to say -20 is probably what I want to be at. And now that's a better way to look at this graph, right? We can see the x-intercepts quite well, and we can see my vertex quite well. We'll go over in our next lessons how to find x-intercepts and vertex and all that kind of stuff. But for now, I just want you to sketch this graph. So that's what you want to do for part C. Okay, so you guys know how to do that one. Now here's the new content. For each equation, find the value of the discriminant. Find the value of b squared minus 4ac. Well, that seems complicated, but all I really mean is, remember our quadratic formula that we did last class? It's talking about underneath the radical symbol. And why that's important is because, remember, there's things called restrictions underneath a radical symbol. What can't be underneath there? Underneath a square root, remember, we can't have a negative number. So we'd say that can't be -1 or -2 or anything like that, right? Has to be 0. It can be 0, but it has to be 0 or larger. So for each equation, find the value of the discriminant. The discriminant is really just the value that you would get underneath square root. So b squared minus 4ac. Then it says look for a pattern between the value of the discriminant and the number of roots and the type of roots. So remember roots, just so you're not, I know sometimes people get confused by that. If that's my graph and I had something like that, remember roots mean the same thing as zeros. Sometimes they're called solutions. They just really mean my x-intercepts. So those are my roots, my solutions, my zeros, whatever. All right. Okay, so here is number 1, and I've got the graph beside me. I'd like you guys to go ahead and do, what was it, A to C for each of these. But what I want to do is just kind of pick up at E. So like we're going to look for this discriminant of each one of these things. And then we're going to start to look for a pattern and see what this discriminant has to do with this graph. So right off the bat, I'm just going to help you find the discriminant. So remember, we're calling the number out front of these things A, B, and C. So this is A, the -4 would be B, and -12 would be C. So if we're putting that into this, that's just saying, well, -4 squared minus 4. A in this case is 1, right? There's like a imaginary 1 sitting out front of there. So 4 times 1, and then C is -12. So we've got -4 squared is +16 minus, well, right off the bat too, what I'm thinking is I've got minus and then I've got a negative in here. So really what I'm saying is plus. 2 negatives make a positive. So I'm going to say plus and then multiply these things in here. So we've got plus 48, which is 64. Okay, so the discriminant of this graph, I've just kind of graphed it already, is 64. What could that have to do with anything? Just keep that in the back of your mind. We're going to see if we can do a couple more and figure this out. Okay, so I've kind of skipped to the next one here and already put in some numbers for you. Just did the same as last time. So this is b squared minus 4ac, but this time we've got 12 squared is 144, and then 4 times 4 times 9 is also 144. So the discriminant of this one is 0. Now look at this graph. See what we can think of here. So the discriminant is equal to 0. All right. Make a prediction on what you think this has to do with this graph. Comparing it again now to this graph when it was 64. Okay, now I'm going to fast forward to this one. If we do it again, discriminant value this time is 28. So this one looks kind of like our first one. If I went back to there, right? It's positive, it's above 0. It looks similar, right? This one was 0, and kind of looking at what happened when it was 0. This was 28, so above 0 again. Now, let's do this one. So let's do this entire one. I'll do like all the steps of this one. So right off the bat, if we try to just factor this one, just make, factor and factor and make that equal to 0. I need to find a number, so it'll be x and x. I need to find a number that multiplies to 5 and adds to -2. Well, the only one that adds to 5 is 5 and 1, right? I can't get -2 out of 5 and 1, so this one can't be factored. So right off the bat, it just doesn't work. So we have to move on to our quadratic equation to find our different roots or zeros or all the different names they can be called. Okay, so we start filling this in. We'd say, so the b value here is -2, a is 1, and here I'll put that, a is 1, and c is +5. So if I fill this in, I've got negative, and then, so negative b, but then -2. Oh, that was weird. So really +2 in the end, but I'll leave it like that. Plus or minus. Now square root, and now I've got my discriminant that's going to go underneath. So b squared, so -2 squared minus 4. A is equal to 1, so that's a 1. C is 5. I'll leave it like that for now. All over 2a. Whoops, and I'll say 2 times 1. The way I left that as an a. 2 times 1. So this turns into, I'm just going to call this +2 because it's a minus a negative, so positive. So 2. And I'll leave this plus or minus for now. And we've got square root of 4 minus 20 all over 2. Now, I'm just going to do it one more time. Let's go 2 plus or minus. This is saying that we've got -16 underneath the square root symbol. Our discriminant is negative 16. So what could that possibly mean? Well, I think it's time to give it away. So if you drew a graph of this parabola, it would look something like this. And I know since this crosses at 5, we'll talk more about this, but the y-intercept is going to be at 5 right there. And it doesn't actually cross the x-axis. So if you have a discriminant, so something that can't happen, right? This is really telling us we were looking for where it crosses the x-axis. At what points does this thing cross the x-axis? That's what we were looking for here. And it's coming up saying square root of a negative number. That's telling us something. That's telling us that it does not exist. They're actually, technically, I guess you could say, there's two roots, but they're two imaginary roots. I kind of talked to some people about this maybe. There's something called imaginary numbers you can have, which really just means square root of a negative 16. For everything we're concerned about, they don't exist. So in the real world, they don't exist. So this is really telling us the square root of a negative number, any negative number, is telling us this thing doesn't cross the x-axis. This is saying, what's the solution for this? This is saying doesn't exist. Yeah, so that's kind of the main point of this. So if I go back and look at my other ones and see if I can find a pattern for this, I go back and say, okay, 28, that was a positive number under the discriminant, or for the discriminant, right? So that underneath the square root symbol of negative b plus or minus square root b squared minus 4ac all over 2a, this was equal to 28. So it's saying this is a positive number. That means I have two roots, or two solutions. If I go back to the next one, this one, if I wrote this again, this would be, minus b plus or minus square root, oh, that's not right, b squared minus 4ac all over 2a. Now this is saying this part is equal to 0. So equal to 0. That's what this was telling us, right? So what that means is we're only going to get one solution of this thing, right? Because if I go plus or minus 0, it's going to be the same thing. So we only have one solution. It's not this if 0 is underneath the square root symbol here, this is only going to ever pop out one solution at me. I'm never going to get two because I'm adding or subtracting 0. So one solution if it's 0, and then if I go back 64, this is just another case where two solutions, right? We got a solution there, we got a solution there. If 64 is our discriminant, so it'd be like plus or minus 64, we'll get two solutions out of that. One will be a positive and one will be negative x. So that's really our rule. So if I'm going to go through, I'm going to skip these ones and I'm going to let you guys do those. Oh, shouldn't see the graph yet. I'll let you guys give those one a try, but what I'm going to go through is this with you. All right, so this little table here, I'd like you guys to fill in because it's going to help you remember what these mean, and this is going to be on our quiz coming up. The first questions will just ask you pretty much this. It'll say how many real roots are there. So if the discriminant is positive, so if the part underneath the square root is greater than 0, then you're going to have two real roots. So two real solutions, right? You're going to actually have two answers to the solution, right? Which also means that you're going to have two zeros, two x-intercepts. You're going to have something like that, right? Two x-intercepts and two solutions that come out at you. The discriminant is positive in a perfect square. Same thing, it's going to be 2 and 2 again. You'll get two solutions out of your quadratic equation, and you'll also have two x-intercepts on your graph. But in this case, they're also going to be rational numbers that'll come out at you. So what I mean by that is it won't be like, how pi repeats forever? It won't be like that. It's going to be some sort of either whole number or some sort of fraction. Yeah, so rational numbers, and you'll have two zeros. The discriminant is 0. So remember, if this is equal to 0, then you only ever get one solution of it. You go plus or minus 0, you only get one solution out of that quadratic equation. So you only end up with one number of zeros, 1. And that would look like, you know, coming down and just touching the x-axis and then coming back up again. The discriminant is negative. So if the discriminant is negative, then number of real roots is 0, number of zeros is 0. You can say here, though, like I was saying, these would be considered imaginary roots. They exist in some universe, just not ours, which is really weird to think about, but apparently that's true. I don't know. So what this is talking about is taking the square root of a negative number, right? So it doesn't exist in our reality. So this table might be helpful. Yeah, so I'm going to end the video there, and I'll see you guys in class. Oh, make sure that you guys actually go back and do all of these questions. This is what I want you guys to do for homework.